Imagine that every star in the night sky slowly begins to fall behind you. At first, nothing feels impossible. Earth becomes a blue point. The moon becomes a gray mark beside it. The sun becomes a brighter star, among many others. The Milky Way still surrounds you in every direction, so the journey can almost trick you into feeling safe. There are still stars ahead, stars behind, and the faint, dusty river of our galaxy wrapped around the dark. But keep going. Move beyond the planets, beyond Neptune, beyond the distant ice of the outer solar system, beyond the last familiar pull of the sun. Then keep going for thousands of years, for millions of years, for longer than human history has existed. At some point, the Milky Way no longer feels like a home you are inside. It becomes an island behind you, a glowing system of hundreds of billions of stars, slowly shrinking into the rear window of a ship. And then, the real journey begins. Because the terrifying part is not simply that other galaxies are far away. The terrifying part is what lies between them. Not a road, not a tunnel, not a field of stars waiting to be crossed, but a void so large that ordinary ideas about travel almost stop working. Before we begin, if you enjoy calm journeys through space, consider subscribing to the channel. Like the video if you want more deep space documentaries like this. And write in the comments where you are watching from and what time it is right now where you live. It is always strange to remember that people all over Earth can be looking into the same universe from completely different nights, mornings, and quiet rooms. Tonight, you are watching the Space for Sleep channel, talking about the terrifying void between galaxies. And to understand that void, we have to begin with a problem that sounds simple, until you really picture it. We live inside a galaxy. That sounds obvious, but it changes everything about how we imagine space. Most of the stars we see at night are not scattered randomly through the universe. They are part of the same enormous system as our Sun. They belong to the Milky Way, a flattened spiral galaxy filled with stars, gas, dust, dark matter, star clusters, dead stellar remnants, and long streams of material, shaped by gravity. When you look up from Earth and see the Milky Way as a pale band across the sky, you are not seeing something separate from us. You are seeing the inside of the structure we are trapped within. It is like standing inside a city at night and mistaking the streetlights for the whole world. The Milky Way is huge on human scales. Even moving at the speed of light, it would take tens of thousands of years to cross its bright stellar disk. A radio message sent from one side would not be a conversation. It would be an artifact, a signal launched by one civilization and received by another civilization so far in the future that the first one might no longer exist. Yet even that enormous size is still only the beginning. Because galaxies are not packed together like buildings in a city. They are more like lonely islands separated by oceans that are almost too wide to describe. The nearest large galaxy to us, Andromeda, is about 2.5 million light-years away. That number is easy to say and almost impossible to feel. Light itself, the fastest thing in the universe, takes roughly 2.5 million years to cross that distance. A spacecraft moving faster than any human-made object ever built would not be slow in the way a car is slow. It would be slow in a cosmic sense that becomes almost ridiculous. It would not arrive in a lifetime. It would not arrive in a civilization. It might not arrive before continents change, species vanish, ice ages come and go, and the entire meaning of home is lost. That is the first hint of the void. The distance between galaxies is not just larger than the distance between planets. It is not just a bigger version of the space between stars. It is a different kind of emptiness. Inside a galaxy, even the dark places still belong to a larger structure. There are nearby stars. There are gravitational landmarks. There is dust. There are clouds. There are remnants of ancient explosions. There are faint signals. scattered objects, and long-term destinations. Between galaxies, almost all of that fades. The sky would not become empty immediately. Leaving the Milky Way would happen slowly. The spiral arms would not end at a sharp border. There would be no sign saying that the galaxy is over. The density of stars would thin. The glow of the disk would flatten behind you. Star clusters would become rare. Gas clouds would become less common. The familiar structure of the galaxy would loosen until it was no longer the environment around you, but an object behind you. That slow transition may be more frightening than a clear boundary. A border would at least give the mind something to understand. A border says, here is one place, and there is another. The edge of a galaxy is more uncertain. It is a thinning of matter, a fading of probability, a gradual disappearance of the things that make space feel navigable. At first, your ship would still be in the Milky Way's halo. A galaxy is not only its bright disk. Around the visible structure is a huge halo of older stars, dark matter, hot gas, and faint debris left behind by smaller galaxies that were torn apart long ago. This halo reaches far beyond the familiar spiral arms. It is part of the Milky Way's gravitational territory, even though it is nearly invisible to human eyes. So even after the main disk is behind you, you would not instantly be free. You would be passing through the outer body of the galaxy. That matters, because the first problem with the void is that the galaxy does not end where the picture ends. Most images of the Milky Way show stars and glowing dust. They do not show the enormous invisible extension around it. They do not show the dark matter halo that helps hold the galaxy together. They do not show the diffuse gas that is too thin to shine like a nebula. They do not show the streams of ancient stars pulled from dwarf galaxies over billions of years. The visible Milky Way is only the bright part of a much larger system. So leaving it is not like flying out of a room. It is more like trying to escape a storm, whose outer winds reach farther than you can easily measure. The farther you go, the weaker the grip becomes. But it never changes from one thing to nothing in a single step. And all of this is still close, compared with the true intergalactic dark. If a ship could somehow keep moving outward, away from the disk, away from the halo, away from the last obvious signs of our galaxy, the view would slowly transform. The Milky Way would become less like a sky and more like a landscape. Then it would become a wall of light. Then a curved glow. Then a wide, silent island of stars. Ahead, there would be almost nothing. Not nothing in the philosophical sense, not true emptiness. The universe rarely gives us that. But nothing in the human sense. No world, no star to orbit, no planet to land on, no asteroid belt worth visiting, no known station, no rescue base, no natural shelter, no ordinary resource stream, only scattered particles, faint radiation, dark matter passing through everything, and galaxies so distant that they look like soft patches of light rather than places. This is why the void between galaxies is terrifying. It is not because it is dramatic. It is because it is not. A black hole is terrifying because it has a shape in the imagination. A supernova is terrifying because it explodes. A hostile planet is terrifying because it has a surface, storms, gravity, heat, or poison. Intergalactic space is frightening because it offers almost nothing to react to. It does not attack like a monster. It does not chase. It does not roar. It simply removes every support that life normally depends on, then stretches that absence across millions of years. The first enemy is scale. Human beings are built for distances that our bodies can cross. A room, a street, a mountain trail, a coastline. Even the largest journeys on Earth still happen inside the same thin layer of air, under the same sky, on the same planet. Space already breaks that comfort, but intergalactic space breaks it again. The distance from Earth to the Moon is large enough to feel historic. The distance from Earth to Mars is large enough to challenge an entire civilization. The distance to the nearest stars is so vast that our fastest probes barely begin the journey. But the distance between galaxies makes even those numbers feel local. If a mission left the solar system and aimed for another star, at least the target would be part of the same galactic neighborhood. Alpha Centauri is unimaginably far by human standards, but it is close enough that we can point to it as a nearby system. Its light reaches us in just over 4 years. A message sent there would be slow, but it would still belong to the timescale of human planning, if humanity ever built technology powerful enough to attempt it. Another galaxy is different. A message to Andromeda would not be late. It would be ancient before it arrived. By the time a radio signal crossed that gap, the civilization that sent it might have changed beyond recognition. Languages would shift, biology might change. Earth might look different. The sun itself would be older. The signal would not say, "We are here," in any practical sense. It would say, "We were here 2.5 million years ago." Now imagine trying to send people, even if a spacecraft could travel at 1% of the speed of light, which is far beyond current human capability, for a crewed vessel. A journey to Andromeda would take around 250 million years. That is not a trip. That is longer than the age of many major chapters of life on Earth. It is long enough for continents to rearrange, for species to rise and vanish, for the descendants of the original travelers to become something that might not even think of itself as human in the same way. At 10% of the speed of light, the journey would still take about 25 million years. That is not a voyage you plan with supplies. That is a moving world. At half the speed of light, which brings its own crushing problems of energy, shielding, time dilation, collision danger, and acceleration, it still takes millions of years by outside clocks to reach the nearest large galaxy. Faster travel changes some of the experience for those on board, but it does not magically remove the distance from the universe. It shifts the problem into energy, engineering, and survival. The void always asks for payment. If you want to cross it slowly, it asks for time. If you want to cross it quickly, it asks for energy. If you want living people to arrive, it asks for a society that can survive inside a machine longer than any civilization has ever existed on Earth. That is why the terrifying void is not empty of problems. It is full of them. The second enemy is the lack of destinations. Inside the Milky Way, a ship could imagine a chain of stars. Even if that chain is difficult, at least there are possible stops. Red dwarfs, white dwarfs, rogue planets perhaps drifting between stars, brown dwarfs, too dim to see easily from far away. Ice bodies, ancient debris. There might be places to refuel if the right technology exists. There might be gravitational assists, scientific targets, backup systems, or emergency refuges. Between galaxies, that structure nearly disappears. There may be some lonely stars that were thrown out of galaxies by gravitational interactions. There may be rogue planets drifting in the dark. There may be faint clumps of matter, thin gas, and unknown small objects. But they are not arranged like islands across a regular ocean. They are rare, isolated, hard to detect, and often moving in ways that would make interception extremely difficult. You could not simply aim for the next safe harbor. The void has no coastline. This makes navigation more than a matter of pointing the ship at Andromeda. A galaxy that looks fixed in the sky is not truly standing still. The Milky Way moves. Andromeda moves. Smaller galaxies move. The local group is a shifting gravitational system. Over millions of years, targets change position. The ship's path must account for the motion of galaxies. The gravitational pull of dark matter halos, the expansion of space on larger scales, the movement of the destination, and tiny errors that grow into enormous misses. Missing a planet is bad. Missing a star system is catastrophic. Missing a galaxy after millions of years would be almost beyond tragedy, because there might be no second attempt. A small navigation error at the beginning, if left uncorrected for deep time, could become a separation larger than a solar system, then larger than a star cluster, then large enough that the ship reaches the general neighborhood of its target, but not the region it needs. In ordinary spaceflight, correction burns solve this. But correction burns require propellant, energy, sensors, reference points, and working systems. Over intergalactic timescales, every correction is also a question of maintenance. Can the engine still fire? Do the sensors still work? Has the navigation archive survived millions of years of radiation damage, software decay, hardware replacement, and cultural change? Can the crew, or their descendants, still understand the original mission plan? This is where the void becomes more than a physical distance. It becomes an information problem. A journey between galaxies would have to preserve knowledge across time. Not just data stored in a machine, but meaning, instructions, warnings, maps, engineering standards, biological records, legal systems, medical knowledge, language. The reason for the journey itself. A ship can carry a library, but a library is not useful if nobody can read it, trust it, repair its storage systems, or understand the context in which it was written. A mission to another galaxy might fail not because the ship breaks, but because the mission slowly becomes a myth. Imagine the first generation leaving the Milky Way with clear purpose. They know the destination. They know why they left. They understand the engines, the habitat, the risk, the calculations, the sacrifice. Centuries pass. Then, millennia. Children are born who never saw Earth. Later generations never saw the sun. Later still, the Milky Way itself is a glowing structure behind them, not a home remembered by anyone living. At some point, the destination is not a place anyone chose. It is an inheritance. That can be powerful. It can also be dangerous. A society that lives inside a ship for thousands or millions of years may change its priorities. It may question why it should continue. It may decide that arrival is less important than survival. It may split into groups. It may preserve the mission in religion, law, science, rebellion, art, or fear. It may begin to see the ship as the only real world and the galaxy ahead as an abstract promise. The void gives people too much time to change. That is a real engineering problem, not just a human one. A generation ship cannot be designed only as transportation. It has to be designed as a civilization container. It has to handle births, deaths, education, conflict, disease, mistakes, repairs, food production, air recycling, water purification, waste management, governance, mental health, and the slow drift of culture. It has to survive accidents, not for days or months, but for historical ages. And the surrounding environment will not help. If a disaster happens between galaxies, there is no nearby planet to mine, no friendly colony to call, no starbase to limp toward, no rescue ship that can catch up in time. Every spare part must come from the ship itself, or from raw materials the ship already carries, or from rare material it can collect along the way. That means the spacecraft cannot be just a vehicle. It has to be a factory, a farm, a hospital, a school, a government, a waste plant, a radiation shelter, a power station, and a cultural archive, all sealed inside one moving object. The word ship begins to feel too small. It would be more like a wandering artificial planet. But unlike a planet, it would have no natural biosphere backing it up. Earth's ecosystems are not efficient because someone planned them. They are resilient because they are huge, layered, ancient, and full of redundancy. If one forest burns, the whole planet does not immediately lose oxygen. If one lake dries, the oceans remain. If one crop fails, other food chains exist. Earth is messy, but that mess is part of its strength. A ship crossing the void cannot depend on that kind of natural resilience. Its life support system would be closed and artificial. Every breath would pass through machinery. Every liter of water would be cleaned, recycled, monitored, pumped, stored, and reused. Every calorie would have to be grown, printed, cultured, stored, or synthesized. Every failure would matter. Mold in the wrong place, bacteria in the wrong loop, a chemical imbalance in a hydroponic farm, a damaged filter, a software error in nutrient supply, a leak in a water tank. All of these could become serious threats. In a normal mission, supplies are counted. In the void, cycles are everything. You do not survive by bringing enough air for millions of years. You survive by keeping air moving through a system that cannot be allowed to drift too far from balance. You do not bring enough water to replace oceans. You trap water inside the ship's economy and fight to keep it from becoming contaminated, lost, frozen in unreachable compartments, locked in waste, or vented through tiny leaks. You do not bring enough food for all future generations. You build a food system that can reproduce itself. A tiny loss rate becomes deadly over deep time. A system that loses only a small fraction of material each year may look excellent in a laboratory, but across thousands or millions of years, small losses accumulate. A little water bound into unrecoverable waste, a little atmosphere lost through seals, a little metal corroded into useless form, a little biological diversity lost during crop failures, a little knowledge lost when training breaks down, a little trust lost after a political crisis. The void is patient. It does not need one disaster. It can win through percentages. This is the third enemy. Time turns small flaws into large ones. On Earth, many systems are allowed to wear out because we can replace them from a global economy. A broken pump can be manufactured somewhere else. A failed computer can be replaced. A burned cable can be rewired. A cracked window can be repaired with materials supplied by a chain of mining, processing, shipping, design, and human labor. That chain is so large that we rarely think about it. A ship between galaxies has to carry the entire chain or recreate it internally. That means it needs mining. Even if the mine is just stored raw material, it needs refining, it needs manufacturing, it needs precision fabrication, it needs electronics production, it needs chemical processing, it needs quality control, it needs trained people who understand not just how to use systems, but how to rebuild the tools that make the systems. It needs replacement tools for replacement tools. This is one of the hidden traps of deep space. The hardest part may not be building the first engine. It may be building the millionth ordinary valve after the original factories have been gone longer than recorded history. Even if the ship carries robots, those robots need repair. If it carries artificial intelligence, the hardware needs power, cooling, memory integrity, and physical protection. If it carries automated factories, those factories need calibration, raw materials, lubricants, clean rooms, error checks, spare actuators, and trained oversight. Automation helps only if the automation itself survives. The void is where every support system becomes part of the payload. Then, there is radiation. Inside a galaxy, radiation is already a serious problem. Cosmic rays, solar storms, and energetic particles can damage cells, electronics, and materials. A planet like Earth protects life with an atmosphere and magnetic field. A spacecraft has neither unless it builds its own shielding. In intergalactic space, the situation changes again. Far from stars, there are no solar storms from a nearby sun, But high-energy cosmic particles still cross the universe. They can pass through thin walls, strike electronics, break chemical bonds, damage DNA, and slowly increase the burden on living tissue. Radiation is not always cinematic. It does not need to glow. It does not need to burn through the hull in a visible beam. It can arrive silently as particles moving near the speed of light. A single particle may cause a tiny error. Many particles over years can damage materials. Across centuries, the damage becomes an engineering environment. Across millennia, it becomes one of the background conditions of life. Shielding helps, but shielding is mass. Mass is one of the most expensive things in space travel. More shielding means more material to accelerate, more mass means more energy, more structure, more fuel, more engines, or slower travel. A generation ship might use water tanks, fuel, regolith-like material, magnetic fields, or thick layered hulls as protection. But every solution has a cost. Water used as shielding must be stored and protected. Magnetic shielding needs power and enormous engineering. Physical shielding makes the ship heavier. Heavier ships are harder to launch, steer, accelerate, and stop. And stopping matters. A journey to another galaxy is not only about leaving, it is also about arriving. This is where many simple imaginations of deep space travel fail. They picture a spacecraft going very fast through darkness until it reaches a distant galaxy. But if the ship arrives moving at a huge fraction of light speed, it cannot simply park. It must slow down. It must match velocities with the destination environment. It must avoid entering a galaxy like a bullet. The energy needed to decelerate can be as difficult as the energy needed to accelerate. A mission that cannot slow down is not a journey. It is a flyby. And a flyby of another galaxy after millions of years would be one of the strangest failures imaginable. The ship would reach the target and then pass through or past it without being able to stop where life could continue. To prevent that, the mission must carry or gather the energy for braking. It may need sails, magnetic interactions, staged propulsion, advanced fusion, antimatter, beamed energy from a civilization left behind, or technologies we have not built. But a beam from home becomes harder across intergalactic distance. A laser or particle beam might help accelerate a spacecraft across interstellar distances if the beam can remain focused and if the infrastructure is enormous. Across galactic or intergalactic distances, beam spread, targeting, energy demand, and the movement of the spacecraft become extreme. The source civilization must keep functioning long enough to support the mission, perhaps across timescales that make the original political promise meaningless. A civilization may be willing to power a launch for decades. Would it power a journey for thousands of years? For longer? The void makes even commitment fragile. If the ship carries all its own fuel, the fuel problem becomes monstrous. Chemical rockets are hopeless for this scale. Even nuclear propulsion, fusion concepts, antimatter ideas, or exotic drives face brutal limits. The faster you want to go, the more energy you need. The more energy you carry, the heavier the ship becomes. The heavier the ship becomes, the more energy you need to move it. This feedback loop is one of the oldest traps in rocketry. The universe does not care how important the mission is. Momentum must be changed, energy must be paid, heat must be managed, waste must go somewhere. Engines must survive. Tanks must not fail. A drive that works for a few years is not enough if the mission architecture needs acceleration and braking phases separated by deep time. The ship may have to wake ancient systems at the end of a journey and trust that they still operate with precision. Imagine an engine that has slept for 2 million years. Then, imagine needing it to fire correctly. That single idea contains more terror than many dramatic disasters. The engine does not need to explode to doom the ship. It only needs to underperform. A valve sticks. A magnetic nozzle misaligns. A control system drifts. A sensor misreads plasma temperature. A cracked component survives at low load but fails during full thrust. After millions of years, even a tiny uncertainty in a critical system becomes enormous. Deep space engineering is not only about strength, it is about trust across time. The fourth enemy is collision. It seems strange to worry about hitting something in a void. Intergalactic space is emptier than the space inside galaxies. But speed changes the meaning of emptiness. At low speed, a dust grain is a speck. At extremely high speed, a dust grain can become a bullet. At a large fraction of light speed, even tiny particles can carry enough energy to damage shielding, produce radiation showers, or gradually erode the leading surface of a spacecraft. The faster you go, the more dangerous the invisible becomes. A ship moving slowly may survive the rare particles and dust it encounters, but then the journey takes unthinkable time. A ship moving quickly reduces travel time, but turns the thin material ahead into a constant hazard. Even hydrogen atoms in interstellar or intergalactic space can become part of the design problem at relativistic speeds. The forward shield must protect against impacts, radiation, heating, and secondary particles produced when high-energy collisions occur. There is no windshield wiper for near-light-speed dust. The front of the ship would need to be treated almost like a sacrificial landscape. It might use thick ice, electromagnetic fields, plasma shields, Whipple layers, repairable armor, or forward drones to detect and clear hazards. But again, every solution adds mass and complexity. A shield that saves the crew may make the ship harder to accelerate. A shield that can be repaired needs materials. A shield that is too thin may slowly fail. A shield that is too thick may make the mission impossible before it begins. In the void, speed is both salvation and threat. This creates a terrible compromise. Travel too slowly and time becomes the main enemy. Travel too fast and the environment becomes a weapon. There may be a narrow range where a mission is barely possible, but that range depends on technologies far beyond what we can currently build, and on survival systems that remain stable far beyond human experience. Then comes the question of light. Intergalactic space is not completely dark. Galaxies shine. The cosmic microwave background fills the universe with ancient radiation. Distant quasars burn across enormous distances. Faint X-rays and radio signals move through the cosmic web. But for human eyes, especially far from any star, the void would feel profoundly black. The Milky Way behind you would slowly become a bright island. Andromeda ahead might grow across deep time. Other galaxies would appear as small smudges, clusters, arcs, and faint points. But there would be no day, no sunrise, no blue sky, no natural horizon. A habitat can simulate light, of course. It can cycle lamps. It can project Earth skies. It can create parks under artificial domes. But everyone on board would know the truth outside. Past the hull, there is no weather, no open air, no natural surface, no season that means anything. Only the ship's internal schedule and the distant galaxies beyond it. This is a psychological environment, unlike any on Earth. Astronauts in low Earth orbit can look down and see home every 90 minutes. Crews on Mars, if they ever live there, would have a surface, a horizon, gravity, rocks, dust, and a planet beneath their feet. Even a lunar base has Earth hanging in the sky, a visible reminder of where human life came from. A ship between galaxies may have no such comfort. Earth would be invisible. The sun would be just one star lost inside a distant galactic glow. Home would no longer be a point. It would be a story. That changes the mind. Human psychology evolved around environments rich in signals. Light changes, weather shifts, landscapes offer scale. Sounds vary. Other life exists. The body senses day, temperature, gravity, smell, distance, danger, shelter, and open space. A closed ship can imitate parts of this, but imitation must be maintained. If the habitat becomes monotonous, the journey becomes not only physically dangerous, but emotionally corrosive. The void does not only isolate a crew from Earth, it isolates them from nature. A living civilization in such a ship would need more than food and oxygen. It would need culture strong enough to survive enclosure. It would need art, education, ritual conflict resolution, privacy, shared purpose, variation, and ways for people to feel that their lives are meaningful, even if no one alive will see the destination. It would need children to grow up without feeling they were born inside someone else's unfinished experiment. That may be one of the most difficult requirements of all. A machine can be tested. A society cannot be tested for 1,000,000 years before launch. Even if we build small closed habitats on Earth, even if we test them for years, even if we learn from submarines, Antarctic stations, space stations, and future lunar or Martian bases, none of those perfectly imitate an intergalactic mission. Every Earth test has an outside world. Every isolated station knows rescue is possible. Every submarine returns to port. Every space station is supported by launches from Earth. The psychological meaning of no exit for generations is different. A crew can volunteer. Their descendants cannot. That raises a moral problem that hides inside the engineering. If the journey takes longer than a human lifetime, the mission depends on people who never chose it. They inherit the ship, the risk, the obligation, and the destination. Some may love that inheritance, others may resent it. Some may believe the mission is sacred, others may believe it is a prison. A stable society must have room for disagreement, but too much conflict could endanger survival. The void turns ethics into life support. How much freedom can a ship allow if survival depends on strict maintenance? What happens if a generation votes to stop the mission? What happens if some people want to change course? What happens if population limits are necessary? Who decides medical priorities when resources are finite? How are crimes handled in a closed world where exile is impossible and prison space is expensive? How does a society prevent tyranny when everyone depends on the same air system? These are not side questions. They are part of the mission design. A badly governed ship could fail even with perfect engines. A perfectly powered ship could collapse if trust collapses. The void provides no neutral ground. There is no separate country to flee to, no wilderness, no ocean, no neighboring city. Politics would happen inside the same sealed environment as oxygen recycling. That makes social stability as critical as structural stability. This is why leaving a galaxy is harder than building a faster spacecraft. The spacecraft must carry civilization without letting civilization destroy the spacecraft. Then, there is the problem of observation. How do you know what waits ahead? From Earth, we study other galaxies with telescopes. We can measure light, spectra, motion, shape, star populations, gas, dust, and gravitational effects. We can map Andromeda better than ancient humans could ever have imagined. But from millions of light years away, detail is limited. A future mission would need extremely precise knowledge of where useful systems are inside the target galaxy. It would need to know which stars have planets, which planets might be usable, where dangerous radiation sources lie, where to enter, where to slow, where to settle, and what has changed during the journey. The information you launch with is old before you arrive. When we observe Andromeda, we see it as it was about 2.5 million years ago. That is not a problem for many kinds of astronomy. Galaxies change slowly. But for a mission trying to navigate to specific stars, old information matters. Stars move, some die, some explode, some pass near each other. Planetary systems evolve. Hazards change. A target chosen at launch may not be exactly where old observations placed it by the time the ship arrives. The longer the journey, the more the map ages. A ship can update its observations as it gets closer, but closer, in intergalactic terms, may still mean extremely far. The destination galaxy slowly grows in detail, but useful navigation might not become precise until late in the voyage. Late corrections require fuel and working systems. If something is wrong with the original target, the ship needs alternatives. Alternatives require planning, energy, and social agreement. Imagine arriving near a galaxy after an impossible journey and realizing the chosen star system is unsuitable. No one can simply turn around. That is another way the void traps you. It forces commitment long before certainty. A mission must choose with incomplete information, then live with the consequences across deep time. Even the destination may not be what people imagine. A galaxy is not a single place. It is an entire gravitational ecosystem. Its outer halo, stellar streams, satellite galaxies, gas, dust, radiation fields, and dark matter structure may extend far beyond its bright disk. Entering a new galaxy would not instantly mean finding a habitable world. It would mean entering another complex region where distances between stars are still enormous. The ship might cross millions of years of emptiness, only to begin another search inside the target galaxy. The void between galaxies is therefore not just a gap, it is a filter. It filters out weak technology, short-lived civilizations, fragile societies, unstable ecosystems, and missions built on optimism rather than endurance. It demands that a species become almost unrecognizable in its patience, engineering, and continuity. It asks whether life can remain organized when the universe gives it no planet, no star, no rescue, no quick reward, and no guarantee that arrival will solve anything. This is why the phrase "between galaxies" is so deceptive. It sounds like a location. But for a traveler, it would be an error. A civilization could be born there, grow old there, change there, and die there without ever reaching the next bright island. Entire religions, languages, political systems, scientific revolutions, disasters, recoveries, and cultural renaissances could happen inside one vessel before a destination filled half the forward sky. The journey would be long enough that the ship's internal history might become richer than the memory of the world it left. And if it ever did arrive, the beings who arrived might not feel like the ones who departed. That is not science fiction decoration. It is a biological and cultural possibility. Over thousands or millions of years, even with careful medical control, populations change. Genetic drift, selection pressures, reproductive policies, medical interventions, artificial habitats, and cultural adaptation could alter future generations. The human body itself may be modified for lower gravity, radiation resistance, closed habitats, or long-term ship life. Minds may adapt to artificial environments. Social structures may evolve around maintenance, energy use, and population balance. The void may not only separate galaxies, it may separate forms of humanity. By the time a ship reaches another galaxy, the travelers may carry Earth's origin, but not Earth's ordinary life. They may be human descendants, post-human societies, biological communities guided by machines, uploaded minds, engineered organisms, or something else entirely. That possibility can sound exciting, but it is also part of the terror. The journey may be so long that leaving the galaxy means leaving behind the species that began the trip. The stars ahead may be reached by someone descended from us, but not exactly us. That is the cost of deep time. Now return to the beginning of the image. The Milky Way behind the ship is shrinking. The black ahead is widening. The crew lives inside metal, water, farms, wires, memory, and rules. Every system has a history. Every repair has a story. Every child is born farther from Earth than anyone before them. The destination is visible, but not reachable in any normal sense. The ship moves, but the universe barely seems to change. That stillness may be the most unsettling part. On Earth, movement gives feedback. You walk, and the room changes. You drive, and the road shifts. You fly, and landscapes pass below. In intergalactic space, even enormous velocity may feel motionless. A ship could travel faster than anything humanity has ever built, and for years the sky would look almost the same. The nearest galaxy would grow by amounts too small for eyes to notice. The Milky Way would shrink slowly. The void would remain. The mind might experience motion as imprisonment. You are going somewhere, but nothing around you proves it. Only instruments, clocks, and old maps say the ship is moving. This is why the terrifying void between galaxies is not only a place of darkness, it is a place where scale strips travel of its emotional rewards. There is no dramatic horizon to cross every morning, no new planet every month, no nearby stars rushing past like snow. Just a slow, nearly silent translation through one of the emptiest environments in the universe. And yet, the void is not truly empty. This matters because the physical reality between galaxies is stranger than simple darkness. The intergalactic medium fills the spaces between galaxies with extremely thin gas and plasma. It can be hot, spread out, and difficult to detect. It traces the history of galaxy formation, supernova feedback, black hole activity, and the cosmic web. It is the faint material between bright structures, the almost invisible atmosphere of the universe's largest architecture. If a spacecraft could sense it, the void might become less blank and more ghostly. It would pass through a medium too thin to breathe, too diffuse to see, and too weak to support life, yet still physically real. Particles would strike instruments. Magnetic fields might thread regions of space. Ancient radiation would remain. Gravity from distant galaxies and dark matter would shape the path. The ship would not be traveling through perfect nothingness. It would be moving through the universe's hidden scaffolding. But that does not make it welcoming. A desert still contains sand. An ocean still contains water. A void can contain particles and still be lethal. The issue is not whether anything exists there. The issue is whether what exists there can help you survive. For human life, the answer is almost entirely no. The intergalactic medium is too thin to be fuel in any easy way, too sparse to be shielding, too empty to provide shelter, and too vast to feel like an environment made for biology. That is the difference between existence and usefulness. The void exists, but it offers almost nothing. In science, the spaces between galaxies are deeply important. They help us understand how matter is distributed across the cosmos. They preserve signs of ancient heating, enrichment, and structure. They connect galaxies through the cosmic web. They show that the universe is not simply galaxies floating in a blank background, but a network of matter, gravity, radiation, and history. For travelers, that same space is terrifying because it is important without being helpful. It tells a story, but it does not keep you alive. This makes the void feel almost indifferent in a pure way. Stars give energy, planets give surfaces, nebulae give material. Even black holes give gravity that can be studied and predicted. The intergalactic void gives knowledge at a distance, but not comfort up close. It is one of the great structures of the universe, and yet a human body placed there without protection would die almost instantly. A suit, a ship, and a civilization are the only boundary between thought and oblivion. That is the basic truth of every deep space mission. But between galaxies, it becomes absolute. There are no environmental backups. The habitat is not one layer of safety. It is the world itself. If the hull is breached, if the biosphere fails, if power is lost, if heat management collapses, if the society falls apart, the void does not become difficult. It becomes final. This is why part one of this journey must stay inside the practical problems before it reaches the more cosmic ones. The terrifying void between galaxies is not terrifying because it is mysterious alone. It is terrifying because once a civilization enters it, almost every ordinary assumption about survival fails. Distance becomes history. Motion becomes patience. A ship becomes a planet. Maintenance becomes culture. Navigation becomes something only descendants may judge. And still, we have only reached the middle of the problem. Because even if a species could build a ship strong enough to leave the Milky Way, even if it could keep people alive, even if it could preserve knowledge, survive radiation, avoid collisions, and continue moving through the black for ages, another question remains. What happens when the universe itself changes while you are traveling? Galaxies are not fixed lighthouses. The cosmos expands. The local group evolves. Dark energy shapes the long-term future. Some galaxies are moving away so fast that over enough time they become unreachable in a practical sense. The night sky of the far future will not offer the same map we see now. The window for reaching certain places may close, not because a ship is too weak, but because the universe's expansion places them beyond any possible journey. That is where the void becomes even darker. Not just empty space between galaxies, but space that may be growing, stretching, and separating future destinations from one another faster than any traveler can overcome. To see why this matters, we have to zoom out from the ship and look at the neighborhood it is trying to leave. The Milky Way is not alone. It belongs to the local group, a gravitational family of galaxies that includes Andromeda, the Triangulum Galaxy, many dwarf galaxies, loose streams of stars, and huge, invisible halos of dark matter. From far away, this might sound comforting. A traveler might imagine that the space between the Milky Way and Andromeda is not true emptiness, because both galaxies are part of the same group. Maybe the gap is more like a wide valley between two mountains than an endless ocean. But that comfort does not last long. A valley still has ground. The intergalactic gap does not. The local group may be bound by gravity, but gravity does not fill space with air, fuel, water, or shelter. It only links the motion of large structures across time. Two galaxies can be connected by gravity and still be separated by a darkness so empty that a spacecraft would spend most of its journey with no useful destination anywhere nearby. That is one of the strangest things about cosmic structure. Gravity can make distant objects part of the same story without making the distance between them friendly. The Milky Way and Andromeda are approaching each other on cosmic timescales. For a long time, astronomers have expected that the two galaxies may eventually interact and perhaps merge into a larger system, although the exact future depends on complex motions and newer measurements. This sounds like it should solve the problem. If another galaxy is coming toward us, maybe humanity does not need to cross the whole void. Maybe the universe will bring the next island closer. But this is not a rescue plan. Even if the galaxies eventually interact, the timescale is measured in billions of years. That is longer than the entire history of complex life on Earth. It is longer than the time remaining before the Sun itself changes Earth in devastating ways. A future galactic encounter would not be a convenient doorway for any civilization alive today. It would be a slow transformation of the sky, unfolding across ages that swallow ordinary planning. And a galactic merger is not like two solid objects crashing. Stars are so far apart inside galaxies that when galaxies pass through each other, Most individual stars do not collide. The shapes change. Gas clouds compress. Star formation can be triggered. Orbits are rearranged. Spiral structures may distort. Giant halos overlap. Central black holes may eventually sink together. But for any small spacecraft, the environment would still be enormous. The merger would not turn intergalactic space into a crowded city. It would rearrange the islands. For a traveler, the void would still be real. There is another reason this matters. If a civilization waits for cosmic motion to do the work, it may wait too long. Stars age. Habitable worlds change. Technology rises and falls. Civilizations may not last long enough to treat billion-year events as practical opportunities. The universe can be patient because it has no body to protect. Biology cannot be patient in the same way. Life survives through local systems. A cell needs chemistry now. A person needs air now. A colony needs heat, food, water, and repair, within real deadlines. A civilization can imagine the far future, but it must survive one generation at a time. The void between galaxies is terrifying because it turns distance into a demand for continuity. It says that a species cannot cross simply by being clever for 1 century. It must remain capable across a timescale where even identity becomes unstable. Then, the scale grows again. The local group is only one small piece of a much larger cosmic pattern. Galaxies gather in groups and clusters. Clusters connect along filaments. Between those filaments are vast cosmic voids, regions where galaxies are sparse, and the darkness spreads across distances even larger than the gap between the Milky Way and Andromeda. When we say the void between galaxies, we may be talking about the space inside a small group, or the even greater emptiness between large structures. The universe is not evenly sprinkled with galaxies. It is web-like. Matter forms a cosmic web of bright knots, long threads, sheets, and enormous empty regions. Galaxies collect where gravity has drawn matter together over billions of years. The spaces between those structures can be unimaginably thin. From a scientific view, this is beautiful. It shows how tiny early differences in density grew into the architecture of the cosmos. From a travel view, it is devastating. It means the universe has geography, and much of that geography is absence. If the Milky Way is an island, the cosmic web is not a neat chain of islands with regular ports. It is a broken map of archipelagos, dark oceans, hidden currents of gravity, and empty basins so wide that crossing one would make the journey to Andromeda look almost local. Some regions of the universe are rich with galaxies. Others are so empty that a traveler could move for ages without seeing a large structure nearby, except as a distant patch of light. That creates a new kind of isolation. Inside the Milky Way, if one star is not useful, another may be reachable on a long enough timescale. Inside a cluster, galaxies may be more numerous, though still separated by vast distances. But in a true cosmic void, the options shrink. A civilization traveling outward might discover that direction matters more than courage. Choose a path along a filament, and there may be future galaxies ahead. Aim into a deep void, and the journey may become a slow exile into a region where the universe itself offers fewer targets. A map becomes survival equipment. Not a flat map, but a living prediction of cosmic motion. It must tell future travelers where galaxies are, where they will be, how fast space is expanding between large-scale structures, which destinations remain gravitationally accessible, and which ones are becoming unreachable. It must distinguish between places that look bright through a telescope and places that can actually be reached by any possible ship. Those are not the same thing. A galaxy can be visible and unreachable. That sentence is one of the quietest horrors in cosmology. Light can cross space and enter our telescopes, while matter, ships, and messages may never be able to make the return trip. The universe can show us something that no future traveler can touch. It can place beauty inside the sky and still lock it behind the expansion of space. For now, the local group is different. Its galaxies are close enough and gravitationally connected enough that they do not simply recede from one another like the most distant galaxies do. But beyond the local neighborhood, the expansion of the universe becomes more important. At very large distances, galaxies are carried away by the stretching of space. The farther we look, the more the universe becomes not only large, but dynamically separating. This means the intergalactic void is not a static emptiness. It is part of an expanding cosmos. A ship moving through it is not traveling across a fixed stage. The stage itself has a history and a future. Over deep time, some routes close, some light fades, some destinations slip beyond practical contact. The idea of a universal civilization spreading from galaxy to galaxy forever sounds powerful until dark energy enters the picture. Then, the dream meets a larger reality. Not every galaxy remains part of the same reachable future. This is why the problem becomes cosmic, not just technological. A better engine helps against distance. A larger habitat helps against survival. Stronger shielding helps against radiation. Smarter navigation helps against error. But no engine can ignore the large-scale behavior of the universe. A species can become faster, stronger, and more patient, and still find that the universe has horizons built into its expansion. That does not mean travel is meaningless. It means travel has a window. There may be destinations that are reachable only during certain cosmic eras. There may be galaxies whose light we can study today, but whose future position is not part of any practical path from here. There may be a difference between the universe we can see and the universe any civilization can ever enter. That difference is not emotional language. It is a consequence of scale, time, and cosmic expansion. The void between galaxies is terrifying because it forces all of these truths together. It is physically empty enough to starve a spacecraft of help. It is large enough to outlast civilizations. It is quiet enough to erase psychological feedback. It is thin enough that even matter feels almost absent. It is structured enough that choosing the wrong path could mean entering a poorer region of the cosmos. And it is changing enough that the sky of the future will not offer the same possibilities as the sky we see tonight. So the question is no longer only whether humans could travel from one galaxy to another. The deeper question is whether any civilization can remain alive, organized, informed, and determined long enough to use the universe, while the universe is still open enough to cross. That is where the second half of the journey begins. Because after distance, survival, navigation, radiation, society, and time, the void reveals its final problem. Even if you are brave enough to enter it, the universe may not wait for you. That waiting begins with a target. A spacecraft leaving the Milky Way would not simply point itself toward a bright spiral in the night sky and go. It would first have to decide what kind of galaxy it is trying to reach, what path through the empty regions around our galaxy is safest, and whether that destination will still be useful when the ship finally arrives. From Earth, other galaxies look like fixed objects painted onto space. In reality, they are moving systems, surrounded by dark matter, wrapped in thin gas, shaped by gravity, and separated by distances so large that even a tiny mistake in direction becomes enormous over time. The nearest major galaxy, Andromeda, is often treated as the obvious destination. It is large, it is familiar, it is bright enough to be seen with the naked eye under dark skies. It is also not a simple target. A journey to Andromeda is not a trip from one city to another. It is a journey across roughly 2.5 million light-years, through a region where the Milky Way slowly fades behind you, and the next great island of stars remains out of reach for longer than human history has existed by many orders of magnitude. There are smaller galaxies closer than Andromeda. The Magellanic Clouds are companions of the Milky Way. Dwarf galaxies drift around the larger galaxies in the local group. But even those are not close in the way planets are close, or in the way nearby stars are close. They sit beyond the comfortable idea of exploration. Reaching them would still require a civilization to solve problems that no expedition in human history has ever faced. Not for months, not for years, not for centuries, but for spans of time long enough to make the original mission almost unrecognizable to the people who inherit it. This is the first terrifying thing about choosing a galactic target. The closer options may not be the ones people imagine, and the famous options may be far beyond anything a biological civilization can personally experience. A crew might leave with Andromeda as a symbol, only to learn that the practical future lies with a smaller dwarf galaxy, a wandering stellar stream, or a faint cluster of old stars barely visible from home. The destination would not be chosen by romance. It would be chosen by energy, timing, resources, braking, gravity, and survival. And that choice matters because the void is not the same in every direction. The universe is not filled with galaxies evenly spaced like lamps in a perfect grid. It is a web. Galaxies gather in groups and clusters. Clusters connect through long filaments. Between those filaments are giant regions with far fewer galaxies, where the cosmic structure becomes thin and lonely. From far enough away, the universe looks like a vast network of glowing threads, and the voids between those threads look like dark bubbles. A traveler trying to cross between galaxies would not only ask how far the next galaxy is, they would ask what kind of cosmic landscape lies between here and there. A path through a richer filament might offer more long-term options. A path through a poor region might leave fewer emergency destinations. A route toward a galaxy group may give future generations several possible targets. A route into a deep cosmic void could turn one era into permanent exile. On Earth, if a ship misses a harbor, another coast might appear later. Between galaxies, a missed target can mean entering a volume of space where there is almost nothing large enough to matter. Even the word almost becomes dangerous there. The void between galaxies is not perfectly empty. It contains thin gas, dark matter, radiation, magnetic fields, high-energy particles, and traces of material pulled from galaxies over billions of years. But for a spacecraft, this does not make it friendly. A desert with a few molecules scattered across kilometers is still a desert. A sea with almost no islands is still a trap. Intergalactic space may contain matter, but not in a form that a human settlement can easily collect, refine, breathe, drink, eat, or turn into spare parts. Inside a galaxy, a starship at least moves through a region with stars, dust, comets, rogue planets, and possible future resources. Between galaxies, the density falls so low that waiting for useful material to come to you becomes absurd. A ship cannot depend on scooping up enough hydrogen to solve its fuel problem, unless it has technology far beyond anything we know how to build. It cannot simply stop at a passing asteroid belt if there is no belt. It cannot plan regular resupply from stars if stars are separated by enormous gaps or absent from the route altogether. That means the ship must carry its world with it. Not just passengers, not just food for one crew, not just fuel for one burn. A true intergalactic vessel would need to carry industry, agriculture, medicine, governance, education, replacement parts, genetic diversity, data archives, repair systems, radiation shielding, communication systems, and the ability to keep all of them working when the original builders are long dead. It would not be a ship in the ordinary sense. It would be a moving civilization with engines. That changes the mission completely. If a spacecraft takes thousands or millions of years to cross part of the void, then speed is only one problem. Continuity becomes just as important. The crew must not only survive, they must remain capable of understanding why they are traveling. The machines must not only run, they must remain repairable by people who did not design them. The culture must not only remember Earth, it must avoid turning the mission into myth, conflict, or ritual disconnected from reality. A map, over enough time, can become scripture. A destination over enough generations can become a promise no one alive has ever seen. This is one of the most overlooked dangers of the intergalactic void. It is not only a physical distance, it is a social distance from the beginning of the mission. The first generation might understand the engineering plan. The second generation might understand the stories. The 10th generation might inherit routines. The 1000th generation might know the ship as the only universe they have ever lived inside. By then, the Milky Way may be an old image in an archive, and the destination galaxy may be a brightening shape on instruments, rather than a place anyone can emotionally understand. A civilization inside the void would need to keep science alive, under conditions where science cannot be tested in ordinary ways. Children would grow up without planets, without open skies, without natural horizons, and without any chance to step outside without protection. Their understanding of galaxies would come from data, lessons, simulations, and the faint light ahead. If the education system weakens, if records are lost, if language changes too much, if trust in the mission collapses, then the ship could still function mechanically, while failing as an intergalactic expedition. The void would not need to destroy the hull to destroy the mission. It could destroy the meaning of the mission. A starship might remain pressurized, lit, and warm, while its descendants no longer agree on whether to continue, where to go, or whether the outside universe described in ancient files is real in the way their ancestors believed. Some may argue that stopping is impossible, so obedience is survival. Others may argue that the mission is a prison built by the dead. Others may want to turn away toward a nearer object, split the population, or dismantle engine systems for habitat space. These are not science fiction decorations. They are consequences of asking biological minds to live inside a machine for times longer than nations, religions, and languages usually survive unchanged. The terrifying void between galaxies is therefore not only outside the spacecraft. A smaller version of it appears inside, between the people who launched the journey and the people who must finish it. Then comes the problem of energy. A ship crossing intergalactic space cannot treat energy as a background detail. Every system depends on it. Heat control, farming, recycling, manufacturing, computing, medical care, propulsion, communication, shielding, lighting, and emergency repairs all require a stable energy source. Solar panels become useless far from stars unless the spacecraft remains near its own artificial power systems. Chemical fuel is not enough for deep time. Batteries are storage, not a long-term source. A mission like this would need nuclear power, fusion power, antimatter, or some technology even more extreme, and it would need that power source to remain stable across generations. That is a brutal requirement. A power plant on Earth can be maintained by a huge industrial civilization. A power plant in a starship crossing the void must be maintained by the same closed population that depends on it for survival. If a specialized component fails and the ship cannot manufacture a replacement, the problem does not remain local. It spreads through the entire habitat. Less power means less farming, less heating, less recycling, weaker shielding systems, reduced computing capacity, and fewer options for course correction. A machine that seems redundant at launch may become irreplaceable after enough time. Redundancy helps, but redundancy has mass. Every backup system requires material. Every spare part increases launch mass. Every extra reactor, tank, printer, pump, valve, sensor, and cable must be protected from radiation, age, vibration, corrosion, accidents, and simple wear. The more self-sufficient the ship becomes, the heavier it becomes. The heavier it becomes, the harder it is to accelerate. The harder it is to accelerate, the longer the crossing takes. The longer the crossing takes, the more redundancy it needs. The mission traps itself inside a loop. More survival equipment demands more energy, and more energy demands more equipment. This loop is one reason the void is so frightening. It punishes every solution by making it part of another problem. A fast ship needs enormous energy to accelerate. A slow ship needs enormous patience and life support. A large ship supports more people and industry, but it is harder to move. A small ship is easier to accelerate, but it may not contain enough people or tools to survive deep time. A heavily shielded ship protects its crew, but shielding adds mass. A lightly shielded ship saves mass, but the crew pays the price in radiation exposure and damaged biology. There is no simple setting where the problem disappears. Then, the ship has to stop. This is one of the easiest parts of intergalactic travel to ignore. People imagine departure because departure is dramatic. Engines fire. A galaxy falls behind. Stars become a background. The ship points toward another island of light. But arriving is not just reaching the neighborhood of another galaxy. It means slowing down enough to be captured, to navigate, to choose a star system, to avoid hazards, and to survive the transition from empty space into a new gravitational environment. If a ship travels very fast, it carries immense kinetic energy. That speed is useful while crossing the void, but it becomes dangerous near the destination. You cannot simply arrive at a galaxy at a high fraction of light speed and gently park beside a star. You must remove speed, and removing speed requires energy, time, fuel, sails, magnetic braking, interactions with gas, or some other method. If the destination galaxy has gas in its halo, perhaps a very advanced craft could use it for braking. But relying on thin gas over huge distances introduces its own risks. Too little drag, and you miss the galaxy. Too much at the wrong moment, and the ship experiences heating, stress, or course instability. Braking may be as hard as leaving. A mission that solves launch but not arrival is not exploration. It is a projectile. It may cross the void beautifully, but it cannot become a settlement. It cannot choose a safe star. It cannot use local resources. It can only pass through the next galaxy like a ghost, spending the destination in a brief blur after millions of years of preparation. To make the journey meaningful, the ship has to arrive slowly enough to act. This creates another cruel balance. Travel too slowly, and the mission may not survive long enough. Travel too quickly, and stopping becomes almost impossible. Carry enough fuel for braking, and the ship becomes heavier at launch. Use external braking, and the mission depends on conditions far ahead that may not be known precisely enough when the ship departs. Aim for a dense region to slow down, and collision risk increases. Aim for a sparse region to stay safe, and braking becomes weaker. The void does not only ask if you can go, it asks if you can arrive with control. And control is difficult, because galaxies are not fixed targets. They rotate, their stars orbit, their satellite galaxies move, their gas shifts, their halos interact. Star-forming regions appear and disappear. Massive stars die. Supernovae enrich space. Black holes feed and sleep. Over the timescales required for intergalactic travel, a destination is not a frozen picture. It is a changing city of hundreds of billions of moving objects. A map built at departure would age. The longer the journey, the more prediction replaces observation. The ship can update its measurements as it travels, But the light it receives from the destination is old, and its own instruments may be limited by distance, dust, angle, and time. By the final approach, the destination will be clearer, but changing course late may be expensive. A small error made early can become a huge correction later. A target star chosen at launch may not be the best target on arrival. A region that looked promising may become dangerous. A safer system may appear, but reaching it may require fuel the ship cannot afford to spend. So the journey must be flexible. Flexibility, again, requires resources. A ship with reserve fuel can adapt. A ship with spare industrial capacity can repair surprises. A ship with strong AI systems can run simulations. A ship with many trained engineers can respond to failure. But every advantage must be paid for with mass, energy, education, and social stability. Intergalactic travel is not a single problem with a single answer. It is a stack of problems, each one leaning on the others. This is why the void is more terrifying than distance alone. Distance can be described with numbers. The void attacks the relationships between those numbers. A million-year travel time is bad. A closed ecosystem for 1,000,000 years is worse. A navigation error over 1,000,000 years is worse again. A cultural system that must remain technically competent for that entire span is worse still. And all of it takes place in a region where help is not merely far away, but structurally absent. In ordinary exploration, danger often comes from what is there: storms, reefs, animals, disease, terrain, enemies, cliffs, currents, pressure, heat, cold. In the intergalactic void, danger comes from what is not there. No nearby star, no planet, no spare biosphere, no harbor, no rescue fleet, no natural rhythm of sunrise and sunset, no outside economy, no easy source of new material, no one close enough to hear a distress call in time. The absence becomes an active force. A broken pump becomes worse because no replacement can be delivered. A medical crisis becomes worse because no hospital exists outside the hull. A crop failure becomes worse because no planet can provide food. A navigational error becomes worse because there are no landmarks nearby. A political crisis becomes worse because there is nowhere else to go. A fire becomes worse because every room is part of the only world. This is the real shape of the void. Not just empty space, but a place where every small failure has fewer ways to end. Even communication changes meaning. A ship leaving the Milky Way may continue to send messages home for a while. At first, delays grow from hours to days, then to years, then to centuries, then to time so long that conversation becomes impossible. A message sent home could arrive after the senders are dead. A reply could return to descendants who speak differently, think differently, and possibly no longer trust the institutions that launched the mission. Communication becomes more like archaeology than conversation. The ship might receive old transmissions from Earth, old updates, old greetings, old science, old news. Eventually, those signals may stop, not because Earth is gone, necessarily, but because the mission has moved too far for communication to remain practical. Antennas fail. Power priorities change. Beams spread. Background noise interferes. Civilizations at home may alter their goals, collapse, transform, or simply move on. The travelers could become the last people who care about the original destination, or the last people who remember the original home. At that point, the Milky Way becomes less a place and more a memory carried in data. This has psychological weight, but it also has technical weight. Without meaningful contact, the ship must make every major decision alone. It cannot ask Earth whether to change target. It cannot request updated technology. It cannot rely on instructions from mission control. There is no mission control in the ordinary sense. Control has to move on board permanently, and onboard control is fragile. A closed civilization must make decisions without fresh outside comparison. It must avoid becoming rigid. It must avoid becoming careless. It must keep experts trained in systems they may never see fail until the day they do. It must keep archives accessible, but not sacred. It must allow change without destroying the mission. It must preserve enough history to understand why the journey exists, but not so much obedience to history that new evidence is ignored. That is a delicate balance for a town. For a sealed civilization crossing intergalactic space, it may be the difference between arrival and slow self-destruction. There is also the biological problem of time. Human bodies evolved on Earth. We evolved under one gravity, within a magnetic field, beneath an atmosphere surrounded by a biosphere, inside day and night cycles, with endless microbial complexity and natural environmental variation. A generation ship would have to recreate enough of those conditions to keep humans healthy, fertile, and psychologically functional. It may rotate to create artificial gravity. It may maintain carefully controlled air pressure, humidity, temperature, and light cycles. It may carry microbial ecosystems, seed banks, animal embryos, medical laboratories, and genetic archives. But biology is not a machine that can simply be paused. Cells mutate, microbes evolve, crops change, diseases adapt. Reproductive health can shift under stress. Populations can lose genetic diversity if they are too small. Social selection can alter behavior. Medical knowledge can decay if not used or taught properly. A small, closed population is vulnerable not only to accidents, but to slow biological drift. A ship may begin as a carefully designed ecosystem and become something stranger after enough generations. The environment inside the ship would be artificial, but the evolution inside it would be real. That means the travelers might not remain exactly the same kind of humans who left. Over long enough times, culture, health, body structure, immune systems, language, and even expectations of normal life could shift. If the ship uses artificial gravity weaker than Earth, bodies may adapt. If radiation exposure is slightly higher than planned, cancer risks and genetic damage may accumulate. If food systems narrow over time, nutrition changes. If population policies become strict, family life changes. If space is limited, childhood changes. By the time the destination galaxy fills the windows, the people arriving may be descendants of humanity in every important sense, but not culturally identical to the people who launched. They may not dream of Earth. They may not want planets. They may see open environments as dangerous and enclosed habitats as home. To them, a galaxy might not mean freedom. It might mean risk. That possibility matters because colonizing another galaxy is not just reaching stars. It is deciding what to do when you get there. A civilization born inside a ship may choose to remain ship-based. It may settle a small star system only if it can recreate sealed habitats. It may avoid planets because planets have weather, gravity, microbes, and unknown chemistry. It may value control more than landscapes. The original mission may have imagined new worlds. The descendants may prefer artificial worlds because those are the only worlds their society understands. The void, in that sense, changes the travelers before they reach the target. It makes them into people of the crossing. Then, there is the question of what they are crossing for. If the goal is survival of humanity, a galaxy-to-galaxy mission makes sense only if the risk at home is greater than the risk of the journey. If the Milky Way remains habitable for billions of years, why leave it? There are hundreds of billions of stars here, countless possible destinations, and far more nearby resources than the intergalactic void can offer. Leaving the galaxy would not be the first choice for expansion. It would be an extreme choice, perhaps made because of a distant cosmic threat, long-term survival strategy, curiosity, or the desire to escape the limits of one gravitational island. But the Milky Way is not immediately ending. It will change. It will merge with Andromeda in the far future. Its star formation will evolve. Its stellar population will age. Some regions will become dangerous. Others may remain stable for immense periods. From a practical point of view, spreading through one galaxy is already a project so enormous that leaving it may seem unnecessary for a very long time. There may be more accessible futures inside the Milky Way than any civilization could use before the sky itself changes. So the terrifying question becomes sharper. Would anyone choose to cross the void unless they had to? Perhaps a civilization would send robotic probes first. These would be lighter, faster, and less fragile than human crews. They could hibernate for long periods, repair themselves if advanced enough, and carry biological instructions instead of living populations. They could arrive first, build infrastructure, map resources, and prepare a receiving system. A human journey might only happen after machines have already made the target less unknown. That sounds reasonable. It also means the first true explorers of intergalactic space may not be people. They may be machines carrying memory, automated arcs, self-replicating factories, seed ships, slow probes that cross the void without boredom, fear, childhood, politics, or hunger. If they arrive, they might build habitats for descendants who launch later, or create biological life from stored information, or simply report that the crossing is possible. In that version of the future, humans may never personally endure the whole void. Our technology may cross first, but that raises a different fear. A machine that can cross between galaxies and build at the other end must be extraordinarily autonomous. It must make decisions without constant human oversight. It must repair itself. It may need to mine resources, copy parts, adapt to unknown conditions, and protect its mission. The more autonomous it becomes, the more carefully it must be controlled. A poorly designed self-replicating system could become dangerous. A system too cautious might fail. A system too independent might no longer serve the purpose its creators intended. Even a robotic solution carries the void's basic lesson. Distance turns instructions into guesses. If humans are on board, the problem is biology and society. If machines go first, the problem is autonomy and control. If both go together, the mission becomes heavier and more complex. There is no version where the void becomes simple. There is only a version where the risk is moved. Another possibility is that intergalactic travel does not begin with crossing the largest gaps. It begins with stepping stones. A civilization might slowly expand through the outer halo of the Milky Way, then to dwarf galaxies, stellar streams, globular clusters, and satellite systems. It might build a chain of habitats, fuel stations, and observatories moving outward over millions of years. Instead of one heroic jump, the crossing becomes a long migration through every usable object on the edge of the galaxy. This is more realistic in spirit. It is also slower, messier, and dependent on finding useful stepping stones where the sky is already growing thin. The outer halo is not rich like the galactic disk. Resources are more scattered. Stars are older. Distances widen. Industrial systems become harder to connect. A chain of outposts must remain maintained across huge separations. Each link depends on the others, yet each link may gradually become isolated by time, politics, or simple difficulty. A stepping stone civilization could survive longer than a single ship, but it could also fragment. The outer settlements might stop caring about the central galaxy. The central galaxy might stop funding the frontier. Different habitats could evolve different cultures, technologies, languages, and goals. What began as a grand intergalactic project might become a loose cloud of separate civilizations, each surviving locally, none willing to push farther into the emptiest part of the route. This has happened on smaller scales throughout human history. Frontiers become homes. Supply routes weaken. Original missions fade. A place built as a temporary outpost becomes permanent because the next step is too hard. The void encourages that pattern. Every outward move makes the next outward move less supported. So even expansion can stall. A civilization may reach the edge of its galaxy and spend ages there, looking outward, building telescopes, studying the next destination, and never fully committing to the crossing. From that edge, the intergalactic void would not look like a single gap. It would look like the end of everything familiar. Behind them would be a galaxy rich with stars. Ahead would be a darkness where mistakes have almost no forgiveness. This may be the most realistic place for fear, not at departure from Earth, and not in the middle of intergalactic space, but at the threshold, where a civilization has become powerful enough to see the route clearly and wise enough to understand what it costs. At that point, the void becomes a decision, not a dream, not a symbol, a decision. And the decision may be no. A mature civilization might decide that leaving the galaxy is not worth it except for probes. It might turn inward, spread through the Milky Way, preserve knowledge, build deep-time habitats, and wait for cosmic events, rather than spend unimaginable resources crossing into another galactic system. It might realize that the void is not only hard, but inefficient. One galaxy may be enough to occupy intelligence for longer than intelligence can maintain a single unified purpose. That is not failure. It may be wisdom, but it is also unsettling, because it means the universe could be filled with civilizations that grow powerful inside their own galaxies and still never meet across the gaps. They may see one another in telescopes. They may detect signs, patterns, signals, or altered stars. They may know others exist, and still, the void may remain too wide, too slow, too expensive, or too dangerous to cross. The result would be a universe of islands. Each galaxy could become a separate story. Each civilization, if it survives, might fill its own stellar home and still remain effectively alone on the larger scale. Communication between galaxies could be delayed beyond practical meaning. Travel could be reserved for machines, myths, or missions so rare that they barely matter to daily life. The cosmic web would not be a road network. It would be an archipelago separated by black water, wider than history. This possibility is terrifying because it changes how we think about abundance. The universe may contain immense numbers of galaxies, but abundance is not the same as access. A person trapped on a small island can know there are continents somewhere beyond the horizon and still be unable to reach them. A civilization inside one galaxy may know the universe is full of other galaxies and still remain functionally confined. The sky can be crowded with light and still be inaccessible. That is the central cruelty of intergalactic space. It shows us more than it gives us. Light crosses the void more easily than life. Photons can arrive from galaxies billions of light years away, carrying images of ancient stars and young clusters. A telescope can receive that light. A civilization can study it, map it, analyze it, and build theories from it. But seeing a place is not the same as being able to enter it. The universe allows information to reach us from distances that bodies may never cross. In that sense, astronomy is a kind of contact without arrival. We can know that galaxies exist. We can know their shapes, colors, motions, and histories. We can measure their redshifts. We can map clusters and voids. We can watch galaxies collide in slow gravitational dances. We can detect ancient light from the early universe. But knowledge does not erase the gap. Sometimes it makes the gap sharper because the more we understand, the more clearly we see what separates us from what we understand. The void between galaxies is not terrifying because it is mysterious in the simple sense. It is terrifying because it is measurable. A monster in darkness can be imagined away. A measured distance cannot. A vague fear can shrink when explained. The intergalactic void often grows larger when explained, because explanation replaces fantasy with scale. It tells us that the space between major galaxies is not a dramatic stretch waiting for a brave captain. It is a region so wide that entire civilizations may be born, change, and vanish before a crossing completes. And if cosmic expansion is included, the larger universe becomes even more severe. Nearby galaxies in the local group are gravitationally tied together. They do not simply flee from us in the same way extremely distant galaxies do. Andromeda is actually moving toward the Milky Way. In the far future, the two great galaxies will merge into a larger system. From a long-term perspective, this means some nearby galactic travel may become easier, in one sense, because the galaxies themselves are approaching each other. But beyond the local group, the story changes. On the largest scales, space expands. Distant galaxies recede. The farther they are, the faster the expansion of space carries them away from us. For extremely distant regions, expansion places limits on what can ever be reached, even in principle under ordinary physics. A civilization can become patient, but patience does not defeat a horizon. A ship can become fast, but if the destination is carried beyond reach by the expansion of space, the problem is not merely engineering. It is geometry and cosmology. This means there are galaxies visible in the sky that are not practical future destinations. Their light reaches us because it left long ago, when the universe was smaller and the path allowed it. But reaching them from here now, or in the future, may be impossible if expansion carries them outside any reachable region. The observable universe is larger than the accessible universe. That difference may be one of the most important truths any spacefaring civilization would have to learn. The sky, in other words, contains unreachable places, not just places that are difficult, places that may be permanently outside any possible journey from our cosmic neighborhood. This turns the intergalactic void into a clock. It is not only a distance to be crossed, it is a distance changing with time. The future does not simply offer more technology and more opportunity. It also removes some opportunities. Galaxies beyond gravitationally bound regions will drift farther away. Their light will stretch. Their images will fade. The universe of reachable destinations may shrink, not because stars disappear immediately, but because cosmic expansion isolates gravitational islands. A civilization that waits too long may become more advanced and less able to go anywhere beyond its local group. That is a strange and uncomfortable idea. We often assume the future makes everything more possible. Better engines, better computers, better materials, better medicine, better energy. But cosmology says the future also closes doors. There may be journeys that are easiest not when civilizations are most advanced, but when the universe is young enough and connected enough for those journeys to remain reachable. The void is terrifying because it is not passive emptiness. It is part of a universe with a schedule. A civilization could look outward, see galaxies glowing across the dark, and know that some of them are already lost as destinations. Others may be reachable only within enormous but finite windows. Still others may merge, fall, scatter, or drift. The map is alive. The roads are changing. Some roads lengthen faster than any ship can follow. Then, the greatest irony appears. The first humans who ever dream of leaving the Milky Way may live far too early to do it. The civilizations that become powerful enough to try may live late enough that many galaxies are already beyond meaningful reach. Too early, and technology is missing. Too late, and the universe has moved on. There may be a narrow era for intergalactic ambition, and we do not know how wide it is. That does not mean no journey can happen. It means the dream is not infinite. If humanity or its descendants ever cross intergalactic space, they would likely begin with local targets: dwarf galaxies, satellites, stellar streams, or eventually Andromeda. They would build machines that can survive without planets. They would create habitats that can last through deep time. They would send probes before people. They would learn to manufacture almost everything from raw material. They would master closed ecosystems, artificial gravity, autonomous repair, long-term governance, and energy sources that do not depend on nearby stars. Each of those achievements is already enormous. Together, they represent something beyond exploration as we understand it. The first true crossing would not be a mission like Apollo, even scaled up. It would not be a rocket launch followed by a landing. It would be a transformation of civilization into something mobile enough, patient enough, and durable enough to carry a piece of life across a cosmic desert. The people who depart may never arrive. The people who arrive may no longer remember departure as lived history. The ship may become more important than any planet. The route may become a homeland. And arrival, if it comes, may not feel like victory. Imagine the destination galaxy at last filling half the forward sky, not as a faint smear, but as a structure. Star clouds, dust lanes, globular clusters, dwarf companions, a halo of ancient stars. The descendants of the original mission watch it grow brighter over generations. Navigation teams refine target systems. Manufacturing crews prepare probes. Biologists test ecosystems for landing habitats. Historians translate old mission files. Children are told that, for the first time, the world outside the ship may soon become larger than the ship itself. Then, the hard part begins again. The galaxy ahead is not home. It is another wilderness. Its stars may contain planets, but those planets may not be suitable. Its radiation environments may be dangerous. Its chemistry may be different in useful or harmful ways. Its gravitational paths may be complex. Its history may have produced hazards unknown from the Milky Way. If intelligent life exists there, contact could be impossible, dangerous, or simply separated by distances inside the galaxy itself. If no life exists, the travelers arrive alone in a new ocean. Intergalactic travel does not end the problem of space. It only moves the problem to a new stage. The first settlement in another galaxy would still need air, water, food, energy, shielding, medicine, construction, law, memory, and purpose. It would still be vulnerable. It would still depend on machines. It would still face local dangers. It would still have to decide whether to spread, stay, return, or continue. The void behind it would make retreat almost meaningless. The galaxy ahead would be vast enough to swallow it. The moment of arrival would be historic beyond imagination. But to the people living through it, it might also be frighteningly practical. Can we slow down safely? Can we find resources? Can we build before systems fail? Can we survive the first local year? Can we teach the next generation what this means? A journey that began as a dream of crossing emptiness would end with the old human problem of building shelter in a dangerous place. That is why the void between galaxies is not only a travel problem, it is a filter. It filters out small missions. It filters out fragile societies. It filters out technology that cannot repair itself. It filters out civilizations that cannot think beyond short lifetimes. It filters out plans that depend on quick rescue, simple fuel, or one heroic crew. To cross it, a civilization must become something that can continue without applause, without feedback, without outside help, and without a guarantee that the destination will reward the effort. Most dreams fail under that weight. Maybe that is why the universe looks silent. Not because life never appears, not because intelligence never rises, not because civilizations never look up and wonder what lies beyond their galaxy, but because the distance between galaxies may be a barrier so severe that even successful civilizations rarely cross it in a way others can notice. They may remain within their own star islands. They may send machines instead of people. They may choose local survival over cosmic travel. They may speak across space with signals too weak, too rare, or too delayed for us to recognize. The void could be one answer to why the universe feels empty. It does not need to kill everyone. It only needs to keep everyone far apart. A galaxy can contain billions of stars and still be a cage on the largest scale. A civilization can spread through thousands of systems and still remain local compared with a cosmic web. A species can master planets, moons, asteroids, fusion, habitats, and nearby stars and still find the next galaxy almost absurdly distant. The scale does not care how impressive the achievement feels from inside it. This is the humbling part. From Earth, becoming interstellar feels like the greatest leap imaginable. Reaching another star would change everything. Building cities beyond the solar system would make humanity cosmic in a way we are not today. But from the perspective of the universe, even an interstellar civilization may still be a creature of one galaxy. It may have crossed ponds, rivers, and seas, while the oceans between galaxies remain untouched. The void makes every earlier step smaller. It does not make them meaningless. It simply places them in a larger map. Earth to Moon, Moon to Mars, Mars to the outer planets to nearby stars to the wider Milky Way, the Milky Way to its satellites to the local group to the cosmic web. Each step feels enormous from the step before. Each step reveals another scale beyond it. There may never be a final crossing where space stops becoming larger. That may be the deepest fear hidden in the title. The void between galaxies is not terrifying only because it is empty. It is terrifying because it suggests that no matter how far life goes, the universe can always become larger again. A civilization may spend 1,000,000 years reaching what its ancestors thought was the edge, only to discover a greater emptiness beyond that edge. It may cross from one galaxy to another and find clusters separated by even more brutal distances. It may reach a cluster and see superclusters, filaments, voids, and horizons. The reward for crossing one darkness may be the discovery of a larger darkness waiting outside it. And yet, there is another side to this. The same void that terrifies also preserves. Galaxies are separated enough that their histories can unfold differently. Stars can form in one place, while another region grows quiet. Civilizations, if they exist, may develop without immediate interference from every other civilization. The emptiness that isolates also protects. The distance that prevents rescue also prevents easy conquest. The void is not only a wall, it is also the space that gives galaxies their separate identities. Without that separation, the universe would be a different place. Galaxies would not be islands. Cosmic history would not have the same structure. The sky would not show distant systems as independent chapters. The universe would lose some of its scale, and perhaps some of its beauty. Terror and beauty come from the same fact. Space is not arranged for our convenience. That does not make the void kind, but it makes it real. A calm night sky can hide this reality. From Earth, the stars make the universe seem full. The Milky Way makes it seem crowded. Photographs from great telescopes make the darkness sparkle with galaxies. It is easy to look at those images and feel that everything is connected by light. In one sense, it is. But travel is a harsher form of connection. To receive light, you only need to wait. To carry life, You must survive the wait. That is the difference. Light can cross the void as a message from the past. Life must cross it as a working system in the present. Light does not need food. Light does not need politics. Light does not forget its mission. Light does not repair a reactor, deliver a child, settle an argument, grow wheat, or choose whether to keep going. A photon can travel for millions of years without becoming tired. A civilization cannot. So when we say the void between galaxies is terrifying, we are not only talking about kilometers or light years, we are talking about the difference between the universe as something seen and the universe as something lived in. To see another galaxy is easy by cosmic standards. To live long enough to reach one may require a civilization to become almost unrecognizable. The ship may need to be a city, a country, a factory, a farm, a hospital, a school, a museum, a power plant, a spacecraft, and an ark at the same time. Its people may need to carry science without outside correction, culture without stagnation, discipline without tyranny, freedom without collapse, and hope without proof. That is not ordinary exploration. That is civilization stretched into a machine. And maybe if a future humanity ever reaches that level, the first intergalactic journey will begin quietly. Not with cheering crowds hearing a countdown on Earth, because by then, Earth may be only one world among many. Not with one crew walking across a bridge, because the crew may number in the thousands or millions. Not with a simple destination, because the mission may include many possible futures. The departure might look less like a launch and more like a city slowly leaving the gravitational story that shaped it. Behind it, the Milky Way would not vanish quickly. For a long time it would fill the sky. Then it would shrink. Spiral arms would become a pattern. Star clouds would become a glow. Familiar constellations would distort and disappear. The sun, if it still mattered to the travelers, would be one unimportant point inside a bright disk falling behind. The ship would enter a darkness where every direction feels too open, and the destination ahead grows only slowly, painfully slowly, across generations. There would be no dramatic border, no sign saying the galaxy has ended. Only a thinning, fewer stars, less dust, less structure, longer gaps, a sky that stops feeling like a neighborhood and begins to feel like a memory. The ship would still move, instruments would still work, life support would still cycle air and water, children would still wake, learn, argue, laugh, age, and sleep. The mission would become ordinary because it has to. Ordinary life is how a civilization survives long distances. That may be the strangest part of all. The most extreme journey imaginable would have to be lived mostly as routine. Meals, repairs, lessons, medical checks, elections or councils, engine inspections, crop cycles, births, funerals, software updates, hull surveys, navigation meetings, waste processing, stories, arguments, quiet rooms, artificial mornings, artificial nights. A civilization crossing the void cannot live in constant awe. Awe is not a maintenance plan. Wonder cannot replace plumbing. Fear cannot recycle water. The void would be crossed, if it is crossed at all, by ordinary days stacked across impossible time. And every ordinary day would depend on not forgetting the larger truth outside the walls. There is no planet beneath you. There is no galaxy around you in the old sense. There is no quick return. There is only the ship, the people inside it, the knowledge they preserve, the machines they maintain, and the faint island of light ahead. That is why the void between galaxies may be one of the most terrifying environments in the universe. It does not burn like a star. It does not crush like a black hole. It does not tear like a tidal force near a compact object. It does not explode, flood, roar, or strike. It simply removes almost everything that life normally uses to recover from mistakes. And then it waits. It waits longer than courage, longer than memory, longer than politics, longer than any single language, longer than the lifespan of the people who made the decision. It waits until a mission becomes a civilization, until a civilization becomes a tradition, until a tradition becomes a question. Why are we still going? What is ahead worth? What did those before us understand that we no longer feel? What happens if we stop? What happens if we arrive? The void does not answer. It only makes the questions unavoidable. This is also why the void is different from the dangers that make better headlines. A black hole can be pointed at on a map. A supernova can be described as an explosion. A rogue planet can be imagined as a dark world drifting alone. These are dramatic objects, and they are frightening because they do something. The intergalactic void frightens in a quieter way. Its danger is not an event. It is the conditions surrounding every event. If a reactor fails, the void makes the failure permanent. If a crop disease appears, the void keeps replacement food away. If a population splits, the void offers no neutral ground. If a navigation system loses precision, the void stretches the error until it becomes a fate. That makes it harder to respect at first. Humans understand visible threats better than invisible limits. We fear the cliff more easily than the long desert. We fear the storm more easily than the slow absence of rain. But the void between galaxies is closer to that second kind of danger. It is not a monster at the door. It is the fact that there may be no door, no road, no village, and no one close enough to notice when the last light inside the ship goes out. For a documentary, that may sound too quiet. For a civilization, quiet can be the most dangerous sound in the universe. For now, we stand far from that crossing. Humanity has not yet sent people to Mars. We have not built permanent cities on the moon. We have not visited another star. We have only begun to send small machines beyond the planets. And even those machines are still near home on the scale of the galaxy. Intergalactic travel is so far beyond us that it can feel like fantasy. But the value of the idea is not that we will attempt it soon. The value is that it reveals the true scale of the universe. It shows that space is not simply a larger version of the distances we know. The void between galaxies is not an empty highway waiting for engines. It is a transformation zone, where travel becomes survival, survival becomes culture, culture becomes memory, and memory must remain strong enough to carry life across a darkness no one was built to cross. If humans ever enter that void, the terrifying part will not be the first moment of departure. It will be the long middle. The era after the old galaxy has become small and before the new one has become real. The stretch where there is no applause, no rescue, no fresh world, and no proof that the destination will be enough. The stretch where the mission must continue because stopping would mean becoming a sealed island in a darkness even larger than the one it hoped to cross. That is the void between galaxies. Not just distance, not just darkness, not just silence. A test of whether life can remain alive, organized, and meaningful after the universe has taken away almost every natural support it ever had. And if one day a ship does cross it, if one day descendants of Earth look back and see the Milky Way as a pale shape behind them, they may understand something we can only imagine now. They may understand that the greatest barrier in space was never only the distance to another galaxy. It was the emptiness between all help and all hope, and the fact that to cross it, a civilization would have to become its own world before it could ever reach another one.